Ever wonder how clean water reaches your tap? It's a journey that starts far away, maybe in a river, lake, or deep underground. But water doesn't move itself. It needs a push. That's where pumps come in. Think of a water treatment plant as a body. Pumps are its heart, constantly moving water where it needs to go. Without pumps, the whole system would stop. These machines are the unsung heroes of modern life, powering every step of water purification. From pulling raw water to sending it through city pipes, pumps work tirelessly behind the scenes. Each stage, lifting, mixing, filtering, distributing, needs a specific pump with a specific job. Engineers design different pumps for different tasks, ensuring clean water for everyone. Let's dive in and explore the world of pumps in water treatment plants. By the end, you'll see why pumps are the powerful, rhythmic pulse that keeps clean water flowing. It's science in action, happening all around you. Why are pumps so critical? Water naturally flows downhill, but treatment plants must fight gravity. The first job is intake, lifting raw water from a river or lake into the plant. Powerful intake pumps make this possible. Inside, water moves through tanks and chambers, each transfer powered by pumps. After screening debris, pumps move water to mixing tanks for chemicals, then to settling tanks. Pumps also create the pressure needed to push water through filters packed with sand and gravel. When filters get dirty, backwashing pumps flush them clean. Finally, high-pressure pumps send clean water through miles of pipes to homes and businesses. Without pumps, water wouldn't reach your tap or the top floor of a building. From start to finish, pumps are the driving force behind clean water. They keep the entire process moving, every second of every day. Without them, the system would grind to a halt. That's why pumps are the true heroes of water treatment. The most common pump in water treatment? The centrifugal pump. It works like spinning a bucket of water. Centrifugal force flings water outward, creating pressure. Centrifugal pumps move huge volumes smoothly and reliably, perfect for intake and high-lift jobs. They're low maintenance and handle water with small solids, making them ideal for the first treatment steps. Now, meet the submersible pump, designed to work underwater. It's a sealed centrifugal pump that pushes water up from deep wells or riverbeds. Submersible pumps are efficient, self-priming, and cooled by the water around them. They're quiet, compact, and perfect for lifting water from deep sources. Both types are essential centrifugal pumps for big jobs, submersibles for deep or submerged tasks. Together they keep water moving from source to plant. Next, the positive displacement pump. Think of a syringe it traps and pushes a set amount of liquid. These pumps deliver precise, consistent flow, making them perfect for chemical dosing. Metering pumps add exact amounts of chlorine or fluoride, ensuring safe water chemistry. They also handle thick, viscous liquids like sludge. Within this family, lobe and screw pumps stand out. Lobe pumps use rotating lobes to gently move fluids. Screw pumps use a rotating screw. Their gentle action is ideal for moving delicate or thick materials like activated sludge. They transport heavy sludges without damage, crucial for waste management. Positive displacement pumps are the specialists for accuracy and tough jobs. They're indispensable for dosing and sludge handling in treatment plants. Where does each pump fit in the plant? Intake. Large centrifugal or submersible pumps lift raw water from rivers, lakes, or wells. Mixing and dosing. Positive displacement pumps add chemicals with pinpoint accuracy. Gentle mixing. Low-speed centrifugal pumps keep water circulating without breaking up flocs. Sludge removal. Lobe or screw pumps move thick, abrasive sludge to dewatering areas. Filtration. Centrifugal pumps provide the pressure to push water through sand filters. Backwashing. High-pressure centrifugal pumps clean filters with a reverse flow. Distribution. High-lift centrifugal pumps send purified water to the community. Each pump is chosen for its unique strengths, ensuring every stage runs smoothly. The right pump at each step keeps water clean and the plant efficient. It's a carefully choreographed system with pumps as the stars. That's how water travels from river to tap. How do engineers choose the right pump? First, they calculate flow rate, how much water needs to move per minute or hour. Next, they determine the head, the pressure needed to lift water and overcome pipe friction. Efficiency matters. The best pump uses the least energy for the job. Upfront cost is weighed against long-term energy savings. Engineers also check net positive suction head, NPSH, to prevent cavitation, which can damage pumps. Durability is key. Pumps must resist corrosion and abrasion from water and chemicals. Easy maintenance and reliable parts are essential for 24/7 operation. The right pump runs smoothly for years, keeping clean water flowing. Smart choices mean safe, efficient water treatment for everyone. Let's see this in action. A city needs a plant producing 45 million litres per day, enough for 150,000 people. The river source is 20 meters below the plant. First, vertical turbine centrifugal pumps lift raw water up. 3 pumps, 2 running, 1 standby for reliability. Inside, precise doses of chlorine and coagulant are added using diaphragm-type positive displacement metering pumps. These pumps deliver chemicals accurately and resist corrosion. After treatment, clear water pumps, large horizontal split-case centrifugal pumps, send water into the city's network. 3 or 4 pumps work in parallel for consistent pressure and backup. Each pump type is chosen for its specific role: lifting, dosing, distributing. This combination ensures safe, reliable water for the whole city. Redundancy and efficiency are built in at every step. The result? Clean water delivered every day thanks to the right pumps. It's a real-world example of engineering in harmony. Pumps make it all possible. From massive centrifugal pumps to tiny metering pumps, these machines are the heart of water treatment. They silently perform the heavy lifting, careful mixing, and final push that brings clean water to your tap. Next time you fill a glass, remember the journey and the pumps that made it possible. Each pump plays a vital role in the symphony of water treatment. Engineers are always improving pump technology, making them smarter, more efficient, and more sustainable. Smart pumps with sensors save energy and predict maintenance needs, helping us face challenges like population growth and climate change. Better pumps mean cleaner water and a healthier planet for future generations. The humble pump is a symbol of human ingenuity and public health. By understanding this process, we become better stewards of our world. The power of the pump is the power to deliver life, one clean drop at a time.